these three things, but later on. So for now, anyways, let's look at this. So this is a battery which has two charges. Well, every battery has two charges actually. Positive and negative. So the positive charge is usually with the red wire and the negative with the black one. But it's not necessary that all of them have to use the same color code for the wires. Moving on, this positive wire, the red wire, is just letting the electrons flow because it has copper inside. It's just the color of the plastic shielding outside it, that's it. So here we have a switch which, if we push down, will not let current flow, and the motor will stop working, stop rotating. Once we turn the switch back on, the motor is going to start running again. So you have a proper current flow depending on which polarity you have. That's right, these are called the polarity. If you put the battery the other way around, it's going to rotate the opposite direction because current is going to flow the other way. For example, if it was flowing this way, that would be flowing the other way, and vice versa. So current flow is very important. If you don't want it to rotate that way, then you have to change the polarity of the battery. So this is how you do the connections. For batteries, you get proper battery holders. You can just use a battery holder. So this was a basic circuit, but remember in the start I told you we'll learn three things: voltage, current and wattage, and I've told you none of those right now. So I just want to explain this at first. So now, voltage is basically the power coming from the battery, and that power pushing the electrons through the wire to wherever the output is, in this case a DC motor. So the more the voltage, the more force is going to push the electrons, and the faster the motor will spin. However, there is a limit. You cannot give it unlimited voltage and expect it to run faster. So for example, you plug in 12 volts in a motor that is only rated for 6 volts, then it will burn up, well, almost immediately. Maybe it will run for a few seconds because it won't be able to take that load. And that's included in how DC motors work and how they're engineered, and that's a different topic. So for now, just keep in mind that you have to keep within the voltage range. If you exceed the voltage, it's going to enter the dangerous zones. But if the voltage is way too little, then it's going to spin with relatively less RPM, very slow, with low speed. So let's get into current. So current is basically the electrons that the voltage is pushing. So the more the electrons, the faster the motor is going to rotate. Voltage basically pushes current through the wires to the output. That's how it works. So here I have written down the short forms, and I have told you what voltage and current is, but I haven't told you what it is. Well, it is basically the amount of energy transfer, the power of electricity. But don't go away, I still have something to share with you. If you want any other type of content, you can comment it down below. I'm just focusing on electrical engineering on the channel, but I am thinking of opening a kind of a study series. So I'm just thinking maybe I could enhance my own knowledge with this, that for every lecture that I get in a day, I come home and make a video based on that lecture, giving my own explanation, so that the students can have better understanding, that they have my as well as the teacher's explanation. And obviously I'll be doing that if I understand it myself. I'm just thinking about that, so you can comment down below. Thank you for watching. Be sure to subscribe and like the video if you have truly liked it, and be sure to comment to give me feedback if you want me to do better, or you can point out any mistakes. You're free to do so.